or different legs, and it's going to be using flows and operators to get the data that they needed, in the format that they required. Also, we'll see that most of the time we don't really need to create these streams of data because the data sources that we are using already provide that flows for us under the hood. So whether you are using data store or room or work manager, all that information is going to be already provided by you. And then if we look at the typical application hierarchy, you will see that we have different layers in our application, and potentially all of them are going to be exposing a type of flow of some sorts. And we'll see why this is important, right? At some point in the view model, we're going to have this state flow, which is going to be an observable data holder type. And kind of the main difference there is there is always an item to be displayed on the screen. That's why it requires special consideration. But this is kind of the content that you can find in that talk. But I wanted to finish up with this kind of recap, just to make sure that, okay, we are going to get a flow, right, from different layers of the hierarchy. But we don't know exactly the implementation details of that particular flow. And it could be, made, or it could be configured in different ways. So we can consider two different types of flows. We're going to have a cold flow that probably, as you know, it's going to produce data only when it's actively collected. And that block of code that is going to produce the data is going to start fresh for every collector. So for example, if we use the flow API, here we have this coroutine, this code that is going to emit three different items. It's going to be quite straightforward. And every collector is going to get these three items in order. If we keep using the water analogy, this is like opening the tap. Like every user, every person is going to get a new fresh stream for themselves. It's kind of the analogy when it comes to cold flows. On the other hand, we're going to have hot flows that is going to continuously emit events, emitting data regardless of collectors. So it doesn't matter if there are collectors or not, data is going to be emitted, and maybe if no one's listening, probably it's going to be somewhat discarded. An API to do that could be the mutable shared flow. This is of type int, and then you can emit to the flow, again, regardless of collectors there. Using the water analogy, this is kind of like a river, right? Water is continuously flowing, data is going to be emitted, and if, as a collector, you are interested, you would go to the bank of the river to access that item. And when we talk about hot versus cold flows, there are some APIs that are going to help us achieve this behavior. So by default, pretty much all flows are going to be cold. And then those using the flow builder or different APIs like flow or as flow. And then if you want to make that flow hot explicitly, you can convert the cold flow to hot with a sharing or stating operator, or simply creating a new flow with the shared flow or state flow APIs. Okay, so now here's the question, right? What type of flow am I getting if I'm subscribing or collecting from the data source or the repo use case? We don't know. And even in the view model, we could assume we are going to get a hot flow, because usually we expose a state flow. Depending on how you configure it, it could have this kind of hybrid mode in which it could potentially unsubscribe or stop collecting from the upstream flows if we use something like the while subscribed starting policy. So again, every layer is going to be a different abstraction. We don't need to go into the implementation details, otherwise we could go mad at it. So what do? The thing is every layer should be doing the right thing. That's it, right? And while this might be a little bit simple, sometimes it can get a little bit difficult and complicated. And this is like this because every layer knows, or every class knows what they are responsible for. So they should know exactly what kind of caching they need to implement or stuff like that, right? So we don't want other different layers of the hierarchy to make assumptions about how a particular flow is implemented. And in this presentation, we are going to be looking at the UI layer. And the right thing there is to stop collecting from the different flows when the app, for example, is in the background, right? When we are not needing the information to display things on the screen. Okay, so that's the recap. We're going to look at how potentially we could be wasting resources of our device if we don't collect properly. And to do that, like we need to do, again, to quickly look at the UI lifecycle, where we know this is true for both Android and KMP. When the lifecycle is at least started, it means like the UI is going to be visible on the screen. And then when it's resumed and above, it's going to be foregrounded. Otherwise, we don't have the UI on the screen. So looking at how we could look at, for example, think about this problem, let's use a maps application. We're going to be displaying the location of the user on the screen. And so, like naively, like we could be having some code like this. I have my view model. I have exposing the location of the user with a flow, location updates, and then I'm going to collect in the onCreate. And you can say, okay, like this is probably, you might feel like this might be a little bit of a smell, but if we look at the equivalent compose code, it would mean you have a composable function, I collect from the same flow, and I use the collectAsState API. It's going to do the same. For as long as this composable function is in the composition, it's going to collect from that particular flow, even if it's in the background. So we are in our app. The user is actively using it. It's in the foreground. We are getting location updates, and that's all good because we are going to be moving the cursor and the position of the user on the screen. And at some point, the user decides to background the app. And one of the problems here is like we don't know when the user is going to come back, right? But because of our implementation, because of the way we collect it from the flow, we are still subscribing to those location updates, right? And we're going to be either like with an active connection to the location like fused provider, and potentially this could consume a lot of resources from the device if we are not careful. So this might be wasting resources, but also depending on the UI toolkit that we are using, it could be dangerous and it could make the application crash if we try to update the UI while in the background. So how do we fix this problem? Again, the expected behavior is going to be to stop collecting from that flow while the application is in the background. If we are in the activity, we could manually call, start collecting in on start, and then cancel that coroutine in on stop. This could be a little bit annoying because we have to do that for every screen and every flow that we have. If we are in a fragment, things get a little bit more complicated because you need to add an observer to the view lifecycle owner and then have that logic in it, and then like how you set it up and then the logic to update the UI. It's kind of mixed up together. The responsibility, separation of concerns might not be like working very well there. And then if we are in compose, it's even a little bit harder. Maybe we need to create the preview states. Again, like listening to the lifecycle changes and do something custom. So to alleviate all those problems, we have the lifecycle-aware Coroutines APIs. They are stable. They're also part of KMP. We have a bunch of them available for you to use depending on how much you want to abstract things away. So we have a few APIs, repeatOnLifecycle. This is an extension function on lifecycle and lifecycle owner. And the flowWithLifecycle API, which is an operator, flow operator. These are going to be available in the lifecycle runtime KDS artifacts. And then for compose, we have the collectAsStateWithLifecycle API, which is also an extension function on stateflow and flow. This is going to be part of the compose artifacts. This has a KMP compatible with an asterisk. We'll see in a second, like the caveat here. So let's see the API definition of these functions. So we have repeatOnLifecycle. This is a suspend function, meaning that we have to call it inside a coroutine. And then it's going to take a state as a parameter and a block of suspend code, right? A block that is going to be running on a coroutine. And repeatOnLifecycle, what's going to do is that every time that the lifecycle is at that particular state, it's going to create a new coroutine and it's going to run block within it. And when the lifecycle falls or below that particular state, it's going to cancel that ongoing coroutine. So what we get is this restarting behavior of a running block and stopping the block every time the lifecycle goes above or beyond that particular state. It's a suspend function, so it needs to be called in a coroutine, meaning at some point it needs to resume the execution of the coroutine, and that's going to happen when the lifecycle is going to get destroyed. So how do we use it? So repeatOnLifecycle, inside the block, we can collect from that flow. And because here we are using started, it means that the collection is going to happen only when the lifecycle is started. And then if we pass in resume, only while the UI and the lifecycle is resumed, while the app is foregrounded. Using it in an activity could be, lifecycle scope. We create a new coroutine. We call repeatOnLifecycle, and inside it we collect. We get the right behavior by default. And then in the fragment, we need to use the view lifecycle owner, not the lifecycle of the fragment itself. But again, be careful because it's a coroutine, right? And when the repeatOnLifecycle function resumes, we shouldn't do anything. We have to be careful and not do anything with the UI, with the view, because at that point, it's going to be destroyed. The flowWithLifecycle API, it's a flow operator, so it's an extension function on a flow, and it's going to return a flow, generic flow. We are going to pass in the lifecycle and then a min active state, and it's going to behave in a very similar way. flowWithLifecycle is going to have this functionality of subscribing or collecting from the upstream flow when the lifecycle is at least in that particular state. And it's going to stop the collection of the upstream flow whenever it falls below that state. Similarly, it's going to take the started state by default as a default parameter value. Here the same, right? And then if you pass the resumed min active state, it's going to collect from the flow when it's going to be the UI foregrounded. Very similarly, like you can use it in that way as well, for example, in your activity code. Okay, the other function, the other API is collectAsStateWithLifecycle. This is the API definition with the extension function on flow, and it requires an initial value. If you use the extension function on state flow, you don't need to pass an initial value. It's going to use the initial value of that particular state flow. And this API is going to return compose state, and it's going to behave very similar to collectAsState. And it's going to update that compose state every time there is a new emission to that flow. With the caveat here, or with the nice thing to have, that is only going to do that when the life cycle is at that particular state. So in your compose code, it's just like this. It's a one-liner, right? Instead of using collectAsState, you use collectAsStateWithLifecycle, and you are going to be doing the right thing by default, right? It's only going to update location, and it's going to only collect from location updates when the UI is going to be visible on the screen. So we mentioned that collectAsStateWithLifecycle is KMP compatible, but if you use a different import, and this is the wrapper that JetBrains has on top of the lifecycle APIs, and this is mostly because most of some of the compose APIs and artifacts aren't still supported by KMP. So meanwhile, you could be using that artifact. You might need to import that dependency. And if you want to see some examples of this, you can check John O'Reilly's open source samples, for example, like Confetti or People in Space that is being used there. Okay, so we are going to have these three APIs. And we're going to do a little bit of a recap because you might think, okay, but do I have to use these APIs all the time or not? I mean, the recommendation is, yeah, like it's not going to hurt. If you use them on hot flows in the end, like when it comes to the implementation detail, it doesn't really matter, right? The hot flow is going to be active anyway, but you're going to be you're going to stop the collection when you don't need it. So, why not? It's all good. Even with cold flows, like if it's like a really pure cold flow, you don't really need it either, because cold flows, depending on how they are set up, it could also stop the producer emitting items. And this is true when back pressure comes in. So if you have a producer that is emitting items, but then back pressure is in place and the receiver, the consumer, isn't using the item, then the producer is going to stop and you're not going to waste resources. But you never know, right, if it's a pure cold flow or not. And when these APIs really shine, it's when you are using they are used in a cold flow backed by a channel or a buffer. And this is because like that buffer is going to keep the producer active, emitting items and producing more and more items. And you might think, okay, I'm not using channels that much, or I'm not using the buffer operator. Doesn't matter, right? Because there are some other common operators that they are using these APIs under the hood. For example, like the flowOn operator, it's doing buffering on your behalf. You may not know. And then you might be wasting resources without noticing. So TLDR, use these APIs because why not, right? Like they are very helpful. Okay, let's go through the implementation details of these APIs. It's not just for the fun of it, it's because I think we can learn like many good patterns and things from the implementation details. So we're gonna see that every API that we introduced is going to use a different low-level API that you can use on your benefit as well. So repeatOnLifecycle is built on top of suspend cancelable coroutine, flowWithLifecycle using callback flow, and collectAsStateWithLifecycle produce state. Suspend cancelable coroutine and repeatOnLifecycle is going to be the harder one because pretty much the rest of the implementations are going to be using that one with the kind of the base and common functionality. Okay, suspend cancelable coroutine, like there are like many talks, many content about this on the internet, so I'm gonna go quickly through that. But it's the way we have to create a new coroutine and jump into the coroutines world. It could be based on a callback-based API or some other asynchronous code that you might have. And the good thing about this API in particular is that it's gonna benefit from structured concurrency, so it's gonna propagate errors and cancellation as expected. So let's forget a little bit about the water analogy. Let's use coffee and imagine that we have this coffee callback API. We are at Starbucks or whatever, and we have this barista, and we want to get notified whenever we have our coffee ready. So the way to bridge this callback-based API into coroutines world, we can create a suspend function that we call prepare coffee. It's going to return actual coffee. And then we are going to use the suspend cancelable coroutine API. We are going to get the continuation parameter that is going to allow us to control the execution of that coroutine. At this point, the coroutine execution is going to be suspended until we manually resume it. The way to resume it is with that continuation object. And whenever we get the callback from the barista, we call the resume. We can resume with a value here, fresh coffee in this case, or we could resume with an error if something happened. Another nice API that we could use on continuation is the invoke on cancellation. So if the caller cancels the execution of this coroutine, we can cancel the order by just doing this. So this is very nice, right? Because we avoid all the complexity of the nested callback functions and all that, and then in our coroutine code, we can call prepare coffee, and sequentially we are going to get the value right there to operate with it. Okay, now the meaty part of the talk. repeatOnLifecycle, how that's implemented. It's going to use suspend cancelable coroutine under the hood. FYI, this code is going to be surrounded by larger thingies that we'll see in a second. But in a nutshell, we're going to get suspend cancelable coroutine. And now we need to implement the restarting behavior that we just saw. So we are going to create our observer, the lifecycle event observer on that particular lifecycle that we are added as observer here at the bottom of the screen. Okay, so we mentioned that when the lifecycle is destroyed, we want to resume the execution of the coroutine. So let's get that implemented. If the event is on destroy, we resume it. That's it. Unit, we don't need to return any particular value with the repeatOnLifecycle API. Now, we need to keep track of when do we have to start the work and when do we need to cancel it. So for that, we're going to have the start work event and the cancel work event. If the event that we get from the event observer is the cancel work event, I'm going to cancel the ongoing coroutine, and that's going to be tracked in this long. So we're going to cancel it, and we're going to set it to move. And now, if the event that we get is then I'm going to create a new coroutine. I'm going to assign it to launch the job. Okay, this add coroutines code is coming from somewhere that we'll see in a second, but imagine that we simply create a new coroutine. And here, potentially, we just need to call block, and that would be right. But we are going to add some spices here just to make things a little bit more safe and secure. And the first thing, we are going to use a mutex. Because it is possible that if race conditions happen, like the life cycle state could be above and below that particular state very quickly, and we want to avoid race conditions. So we're going to guarantee that block is going to get created and cancelled, serially with this mutex. And we're going to use an internal before calling block because we want to wait. Scope is giving here some safety guarantees as well, that we are waiting for the block to finish. Okay, where is this coroutine scope coming from? That's going to be the first thing that we do when we call repeatOnLifecycle. It's going to be there, the first line. Why? Because a good practice in coroutines, in this case, is to preserve the calling context. When someone calls repeatOnLifecycle, they want to make sure that block is executed in the same coroutine context where the previous coroutines code was executed. And because we need to register an observer to the lifecycle, we need to do that on the main dispatcher. So we preserve the calling context using coroutine, and then we move the execution of the coroutine to the immediate dispatcher so that we can call suspend cancelable coroutine, which is going to add a new observer, and then we do the try so that finally, whether we get a cancellation or whether we resume executing the coroutine, we cancel the launch job, and then we remove the observer from the lifecycle. Okay, I think hopefully like everyone understood this. So a few nice things here, right? Like the coroutine scope to preserve the calling context, and then like mutex and coroutine scope to make sure that block finishes successfully. Cool, callback flow. Not much to say anything here. We know that this is a way to create a flow and emit items from any other like async solution that you might be using. For example, like it could be a callback-based data stream as well. It can handle back pressure. We'll see later how to do that. So again, with the callback API, now we are interested in listening to all the orders that the barista is preparing. So, and we want to get those orders as a flow instead of using this API. And for that, like we're going to get a function. We can define it, coffee orders. We are going to get a flow of coffee order type. We create a flow with using a callback flow. Callback flow is actually going to produce a called flow, so that just to link that with what we learned earlier. And then on every coffee order that we get from the listen function from the barista, then we're going to call try send. That this is a non-suspend function, right? So this is going to be best effort. We are going to try to add it to the call to the flow that we created, and then we are going to use the await close API to wait for the collector to go away before we stop listening to the barista. In our calling code, we create this coroutine, and we can collect, and then every order that comes with a manual name, I'm going to drink it. I love coffee, so why not all of them? And then how flowWithLifecycle is using callback flow. It's like this is the first thing that we are calling. Callback flow, something that I didn't mention earlier, is that it creates a new coroutine. So right now we are in a coroutine context, and we can call repeatOnLifecycle. So again, you see like we are using the repeatOnLifecycle here as kind of the base functionality that we are going to keep reusing for other high-level APIs. Lifecycle, repeatOnLifecycle, when we collect it, now we use the send API to do it. This is going to add back pressure, right? So if the collectors are not getting the item, we are going to wait for them. So in this particular case, we wouldn't be wasting resources, but this is safer to use. Because repeatOnLifecycle is going to resume executing when the lifecycle is destroyed. When that happens, we just close the channel, and then we inform the collector that that's it, that there are no more items that are going to be sent. The other API is going to be that we're going to be using is preview state. This is what collectAsStateWithLifecycle API is using under the hood. And probably you're familiar with this, with compose, that this is the way we can create compose states. And we are going to bridge asynchronous, potentially coroutines code, and we are going to be updating and hooking to the compose's reactive state model. The nice thing about this API is that it's already going to handle the coroutines code for you, and cancellations and all that. So probably you know how this works. So preview state, every time that you give a new value to the value parameter, then it's going to update the compose state, and it's going to cause a recomposition in that particular composition scope. Cool. So collectAsStateWithLifecycle. The implementation details is returning compose states, and then we are going to call produce state as soon as we start this function. We're going to pass all the parameters that we have to the produce state API, so that, like, should any of these parameters change, we are going to restart the block of code that produce state is going to do, the coroutine that it creates. Inside it, we call, again, very similar to the flowWithLifecycle API, lifecycle, repeatOnLifecycle, we pass in the min active state, and with the collect function, like the to-do there is going to assign the value that we get from the flow, and we update the produce state value. I didn't mention it earlier, but we are passing a coroutine context as well, which is optional, and that's we can use the with context to switch the context to whatever the developer might be interested in. And this is going to change where we are collecting and where we are going to be emitting those items from. Cool. So that's been like the implementation details of the 3 APIs. Main thing there to notice is that we are using repeatOnLifecycle as the foundation of all the work, all the complexity there. And this is kind of a good segue to how to build good APIs. Coroutines APIs mostly. We need to make sure that we comply with the structured concurrency. We preserve the calling context as much as possible, but also we propagate exceptions and cancellation as expected. Otherwise, developers using your API are not going to have a great experience. Good design as well is foundation for higher level APIs. At some point, we'll reach the limit, right? But as much as possible, if we separate concerns properly, we can have enough granularity so that developers can hook into the right place and the right functionality that they need, and they could potentially build on top of it. Also, we need to have some sort of emphasis on explicitness and safety. We don't want to create like any race conditions inside it, any unexpected things to happen. The API should do what it's meant to do and nothing else. And then potentially educational value, right? If we are following good practices with APIs, anyone reading our source code should be learning like new things and should be happy with all of that. And everyone kind of makes mistakes. And so we also want to see, show one example of not so good design. And this is an API that actually landed in the first alpha version when the team released these APIs. And that's the @repeatingJob API. And we kind of added this API because it was a little bit annoying to have to create a new coroutine and call repeatOnLifecycle every time that we wanted to collect from a flow in the UI. So we said, okay, @repeatingJob seems convenient, right? And this is the API definition. It's going to be quite easy. So just to save that one line of code, it's going to return a job, and it's going to do exactly that. Lifecycle scope.launch, and then repeatOnLifecycle. Very easy, very convenient. But there are problems with these APIs, right? The first thing, as a spoiler alert, it's not respecting structured concurrency. So imagine that here we are in our activity, and there is some expensive init work that needs to happen. And then, like, naively, again, I can do, okay, I'm going to do some init work, and then I'm going to call @repeatingJob, and then I'm going to collect from this. And then anyone could think that if I cancel job, I'm going to cancel the repeating job, but that's not the case. @repeatingJob, even if you cancel job, is going to keep collecting because it doesn't preserve the calling context. It's creating a new coroutine under the hood. And what's misleading here is that @repeatingJob is not a suspend function, and that's the catch, right? So we need to be very careful about how others perceive our APIs that we create, and we need to make, we need to be as safe as possible for things like this to not happen. So that's pretty much everything that I had for you today. More resources if you want to learn about this topic. You have a bunch of blog posts available to read. And kind of the main takeaways for this talk is that every architecture layer in your hierarchy should do the right thing. And not just the right thing, assuming that I'm making assumptions about how this other part of the hierarchy is doing or not. It's about, hey, I'm in control. I know what's my responsibility, and I know what I need to do. If I need to, if I'm doing, for example, expensive operations, and I need to switch to a different dispatcher, it is my responsibility to do so. I shouldn't expect other parts of the code base to make those assumptions for me. So every arc layer should do the right thing. Collect using lifecycle-aware APIs. It's been like 40 minutes of bombing you with this information, but hopefully it's a no-brainer. You just need to import the right libraries. Create good APIs that comply with the structured concurrency. This is really important if you want the APIs to be used by your colleagues and people in the community. And a good thing to keep learning more and more is by reading the source code of what others are doing, reviewing PRs and all that. Thank you so much. I hope you learned something new today. I'm going to be around, so if you need any questions.